Hey everybody, I just wanted to give you some more examples with the scatter plots. Yesterday you watched Professor Berger with the 2 videos. Today I have just 3 more examples that I wanted to show you as well, and then the worksheet that follows. So just follow along with me. You can print out these sheets or you can just kind of take notes as you go through in your notebooks. But let's take a look at number 1. Number 1 says here, the final question on a math test reads, how many hours do you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on the test. So taking a look at the data, we have the number of hours studying and the test grade. So remember, in terms of setting them up, our number of hours are going to be the X values and your test grade is going to be the Y values. So remember that your test number of hours that you're studying causes what you're going to get on the test. So no hours studying, they got a 75. Half of an hour, they got an 80, 1 hour an 80, and then so forth. And then the last one, 4 hours, they got a 90. So the question in number 1 says here, make a prediction about the relationship between the number of hours spent studying and the test grades. Well, you can see as you go through this chart that they gave us with this data that we can generally say a trend would be the more hours that you spend studying, the higher that your grade's going to be. Okay, and that's just what we're going to do for number 1. So here, number 1, the greater number of studying should correlate, okay, which is one of the words that we're using here with the scatter plot, should correlate with a higher grade. Sorry that my writing is atrocious there. All right, so in part B, it says here, now make that scatter plot. So now we're going to take this data from the table and put that on the actual graph. Now you're going to say one thing, what is missing from the graph? So they have here the hours spent studying, your test grade, and of course, Ms. Feely would always say that they're missing. They'll tell you, you have to tell me what we're talking about. So let's just put a title in here. We have math scores versus study. Okay, and your title can be different, doesn't matter. All right, so now I'm just going to plot some of these points. Okay, so for no hours, they got a 75. Okay, so that's about here. Half hour was an 80, so somewhere around here. I don't know why this keeps doing it, maybe because I keep touching it. Half hour an 80, 1 hour also an 80. 1 hour and 85. Okay, so it's going to be up a little bit. My points are all off. Let's maybe not do this here. 1.5 hours, that's going to be an 85 as well. All my points are off. Do me a favor and just plot them, or just know that where our points are going to be, okay? And then I just want to put this last point. 4 hours is going to be a 90, okay? So it looks something like this. All right, so what trend do we see with the data? So if I would make a line of best fit, now remember with these scatter plots, you're not connecting every one of your values. That line of best fit would be like the equation line. There's not necessarily an exact equation for every half hour or whatever it might be that you study, you get a certain grade. This is just kind of a relationship between your X and Y values. So in terms of the trend, we can say that typically the more you study, the more your test score will go up. So more studying, and just say higher or better grade. So part 1B says, do you think that studying 10 hours would greatly increase your grade? I'm going to say no. Because if you look at, even like in the last one, for 4 hours, they got a 90. It's not like if you continue to study, you're going to get a 100 or a 150 or 200. That's not possible. Sometimes you can overstudy, kill your brain, right? So in this case here, I'm going to say no. The graph shows a general trend upward, but your grade can't exceed 100. So I'm going to say no. And then part 1C says here, why might a student who studied fewer hours make a higher score? Well, it could be a couple different factors, right? You guys know, they could just by chance get a good grade. Maybe they know their content where they've really paid attention in class. The textbook has here the subject matter might be easy for the student to understand, so they might not need to spend as much time studying. Maybe it might not come natural to them, or whatever it might be, or they just by chance got a good grade. So you can write that in right here, okay, whatever your value might be. All right, let's take a look at the second example. So for Professor Berger, from looking at the examples yesterday, remember we talked about the correlation. You have a positive correlation. As your x values increase, so do your y values. A negative correlation means as your x values increase, your y values are going to decrease. And then this last one, that last one is going to be a no correlation. There's no relationship between your x and y values. But I wanted to point out this little part in here. Okay, so it says here, when data shows a positive or negative correlation and falls along the trend line, so like this here, we can say that there's a linear association, or like a correlation, a linear correlation between the two. However, like in the last one, when the data shows a positive or negative relationship but does not fall along the line, that is a non-linear association, or sometimes we know them to be the outliers. All right, so let's take a look at number 2. Susan surveyed 20 people about the price of a cleaner product she developed. She asked each person whether they would buy the cleaner at different prices. A person may answer yes or no to more than one price. Susan's results are shown in the table. All right, so we have the price and then we have the buyer. Okay, so the price is going to cause in terms of how many buyers. So notice that typically we can say, so for the first one, I should say here, if it was $2, you had 20 buyers. If it was $4, you still have about 19 buyers. $6, it would be 17 buyers. 8 would be 13. $10 for that price of cleaner, you have 8 people, and $12 the price, you would have 2 people buying it. Okay, so we can typically say the cheaper it is, more people that would buy it, okay, in terms of a range. All right, so we're going to take that and plot those points. So you have 220. You have 419. You have 617. Sorry, my graphing is way off. It's hard to do it on the iPad. Oh, they're like way off. Just do me a favor and do them yourself, or imagine where those values would be. 6, I did 6, I think. 8, 13. Seems like my smartboard at class too, right? Okay, so just imagine your points here. They would be something like this. Let's say like something like that. All right, so it says here, describe the type association you see between the price and the number of people that would buy it. Okay, so this would be a negative correlation. As the price goes up, typically the less buyers you're going to have. Okay. All right, let's take a look at some more questions here, or another example. Okay, so give me a second. I'm going to go and bring up this other sheet. All right, so reading the top of the example, I don't know if you can see it. I can see it, but I'm not sure if you can. It says here, when a scatter plot shows a linear association, okay, so all your points lie within a trend line or around a certain value, it's not a no correlation, you can use a line to actually model the relationship between your variables. So the trend line is that line that comes closest to the points on your scatter plot. Remember, it doesn't connect all your points. It just kind of helps you see the relationship between your x and y values. But you have these outliers, okay, sometimes in the data set that's very different from the rest of them. All right, so Joyce is training for a 10K. For some of her training runs, she records the distance that she ran and how many minutes she ran. So once again, you have your distance, okay, on the x-axis. We have our time on the y. So depending on how far she goes, gives a certain time, okay? All right, so 4 miles took her 38 minutes. 2 miles took her 25, 1, 7, 2, 16, 3, 26, and so forth, okay? All right, so in this case here, we're just going to plot all of their points. Imagine with me, I'm sorry I can't do this for some odd reason, but yeah, it's not working. I'm just going to kind of go off of my answer key and just do something like this, okay? It's not accurate. I'm sorry. It is what it is, okay? Okay. All right, let's take a look. Let me draw now a tread line. So it says here, to draw the tread line, use a straight edge with a ruler, okay, or like the binding of your book, to draw a line that has about the same number of points above or below, okay? And ignore, notice that's important because you're going to see a couple questions like that. Ignore any outliers. So you just start where your data starts. Looks something like this, okay? All right, now we can use this line because we've done this before. Use a line to predict how long it would take her to run 4.5 miles. So we're going to go to 4.5 and go up and go over to figure out that distance, okay? So we can say that's about, or from her data that we have here, if she runs 4.5 miles, that's going to take her about 45 minutes, okay? Is that going to be 100% accurate? Well, no. There's lots of things that go into that, but we can use that to kind of help us. All right, then questions 3A and 3B here, okay? So 3A says, how well does your trend line fit the data? So notice that all your points, and I know I just kind of put them on there, all of our points come close. So it's showing that there's a strong positive correlation. Notice it's not for every value, but they're all right around the same. 3B says here, do you think you can use a scatter plot that shows no association to make a prediction? Well, the ones that have no correlation or no association are very hard to do because all the data is like scattered. Like a no correlation would be, like for instance for you guys, like in class, if I were to take everybody's hair color and their shoe size and compare them, you would see that there wouldn't be a correlation. So I can't predict, oh, well, the more people that have brown hair have a bigger shoe size. Like, that makes no sense. So in this case, it would be hard to determine the relationship when there's no correlation or no association for that. All right, you'll see here, I've attached a worksheet for you to do. You are doing, I forget what number it is. I think it's numbers 1 through 9. All right, I'll see you guys later.